Hi everyone, my name is Dominic Arajado. I'm a web developer, and this is your guides, tips, and tricks to web development. So in this video, I'm going to show you how to set up a local development for NestJS projects using Postgres as your database. So a little bit of introduction about NestJS is a progressive Node.js framework, so similar to the likes of ExpressJS. So previously, I was using ExpressJS for my server-side application, and that didn't come with a TypeScript by default, so I have to configure that on my own. So although that's a small thing, what I like about NestJS is that it encourages you to use industry standards and best practices when building your server-side application. So concepts and abstractions such as modules, controllers, services are really great. And also I just got to learn about the concept of data transfer objects. So everything when you start building your NestJS projects, you can see how well structured the code is and how easily you can, reuse services and read the code, and it's really, really clean. So if you're new to NestJS, I highly suggest to check it out. And once you already hook into it, I now going to show you how to set up a local development that's productive and efficient, so that you just have to run one or two scripts, and when there's another developer who's going to integrate or develop in your NestJS projects, it's easier for them. So they already have like a NestJS up and running connected to a local database. So yeah, without further ado, let's get started. To quickly get started with NestJS, you want to install their CLI. NestJS CLI. So a couple of assumptions right here is that most of the technologies right here, you should have some basic basic knowledge like Yarn, NPM, Node, JavaScript, TypeScript, and all that. I won't go into the detail of those technologies, but I am going to explain each of the steps that we're going to do. But I will add references that you can read more details about in the description below. All right, so open your terminal and run this command to install the CLI of NestJS. I already run this, so I won't be running it again. And after you install that, you should be able to run the Nest script to basically create a NestJS project. So Nest space new, and then the project name. I'm going to name this as NestJS Postgres boilerplate. I already run this before, so I won't run it again. Once installation, it will actually ask you which package manager you're going to use. So just select Yarn as well to make it in line with what package manager we're using. And then once that's done, let's open our boilerplate NestJS application. So just to quickly test that everything is working fine, you can do a yarn start dev. This will basically run the NestJS application in dev mode. All right, so we can access it on port 3000, as that's where it's listening to. You can look at the main.ts. It's listening to port 3000. And now it's working fine because we do see the hello world message. So yeah, our NestJS is working fine. So just to quickly show you as well how to build this for production, you can run the yarn build script. And then later on, once that's build is done, you can run yarn start semicolon prod. Okay, build is done. It will generate a dist folder, which is basically all the files in JavaScript. So it's ready for these are all the files for production. Yarn start prod. That will basically do the node this to the main. And yeah, same logs. I refresh this page and I should still get the hello world message. All right. So now what we're going to do before that, I just want to also show you what extensions you'll be using. So I'm using Visual Studio Code as my editor. I also suggest for you to use that because we're going to use some of the extensions right here. So one is prettier. So prettier is a code formatter. Anytime you change, you write code and you save the file, it will automatically format the code for you, and that's good. That's a good time saver. As well as ESLint. So it basically show you any programmatic or styling error on your code that will notify you and show you like squiggly lines over here. So those two, do install that. And after you install those packages, extensions, for Prettier specifically, you have to add this settings JSON just in case another developer has its own settings in their local. This will override it. And you just want to add editor default formatter. We want that to be the Prettier. And format on save to be true. And just the tab size to be 2. We're using 2 here because by default NestJS also uses 2, just to keep things aligned. And when you initialize NestJS, they already provided you a prettier config. So we're just going to use that as well. All right, to quickly test if our prettier is working fine, let's try to add some extra space over here. And once I click save, then boom, there you go. It automatically format the code for us. So that's great. And now let's move on to basically containerizing our application. So when you deploy it to production, the most common use case is to use Docker or containers. So basically, containers are like isolated kind of operating system. They have their own host, they have their own networking. All processes are isolated from your host. So when I say about host, it's basically your own computer. So it's separate from that. It makes your application more portable to other developers, or when you deploy to production, yeah, there's isolation in it. And it's when in isolation, it provides less chances of having errors that's related to the system. So Dockerfile is a way, Docker is the way to go for when deploying this kind of application such as NestJS. So before starting into Docker, you need to create a Dockerfile. So Dockerfile is like instructions for Docker on how to build your image. So to start with, I'm just going to put here the directive. So this is optional. Basically, it's just telling Docker what version directive it should use. So this is more for like older versions of the Docker. So this is optional, but it's just good to have. And then in every image, you will have a base. So since this NestJS is a Node.js framework, our base would be Node. So what I like to do is basically go to the Node.js and check for the version that's recommended for most users. So that's 16.14.2. And then there's different kinds of versions for Linux. And if you go to the Node Docker from Docker Hub, you'll see that there's different kinds of versions for Linux for you to use. There's Alpine and a bunch of other things. I like to use Alpine because Alpine basically is like a slimmer version of the Linux. But there's some caveats to it. You might face some issues, but most of the time I didn't face any issues. And if we have a slimmer version of the Linux, that makes it faster to build the image itself. So yeah, if in case you face any issues, just use without Alpine, but in this case, I'm going to use that. And then using the env key, you can define the environment variable. Since this is for production normally, let's just add production for now. Later, we'll be doing one for development. And then we want to set the work directory as app. So after this, any subsequent commands will be using work directory as our directory. So we don't have to keep repeating it when we execute commands after this line. So this is the first command. Basically, we want to copy package JSON and then the yarn lock. The yarn lock sometimes have versions. So we just have the asterisk over here so that it will select anything that starts with yarn.lock and then basically paste it in this directory, which is our working directory, right? So now that we have package and yarn lock, we can basically, this is the only two files that we need when we install packages. So we can run the command run install, and we have to pass a parameter over here, frozen lock file. So in cases when you do a yarn install, if there's new versions in the package.json, any dependency here would basically override the version in your yarn.lock, and we don't want that because sometimes it might break your application. So we're just gonna freeze what is the version specified in the yarn.lock. And then of course this is production. We pass the production parameter, which basically only installs dependency and not the dev dependencies. Okay. And in production, we need to build our NestJS application. Well, before that, we also need to, after installing the dependencies, we can now copy all the files over here. So copy from this is the context here. And then the next context is the app, which is our working directory. So notice we don't have to do this, because we have the working directory. All right. And then yarn build, right? We actually have to also add the NestJS CLI in order to build the NestJS for production, because NestJS CLI is not, when you install the packages, it's not part of the dependencies. So we have to install it here, and then only we can run yarn build. After that, we basically have the image for the NestJS. We now can have the command. So basically, when we run this image, what script should we run? So that, remember, we use yarn start prod to basically run that image. So basically, when we do a Docker build, which is to build the image, we will only read all these instructions, and then the command is for running the image itself. So later you'll see that. Basically, we're done for the Dockerfile for now. Let's just also add a Docker ignore. Basically, ignore, when we're doing a copy, we want to ignore copying the node modules and the this folder, so that, you know, it makes it faster to build the image. Now to build an image, you can use Docker build, and then it accepts a parameter tag. This is basically to name your image. It also accepts an optional tag. So basically, for example, I'm going to use nest docker as the name and then a tag. So we're not going to use the tag over here. We're just going to use the latest, which is already going to be added by Docker itself if you didn't provide the specific tag. And then we just add the context. So just dot. This would be our context when building the image. And then it will read the Docker file. So for the first time, it will take some time for it to build, because this is your first time building the container, but subsequently it will use the cache. All right, so now our image is successfully built. We can now run it. So to run our Docker image that we have created, we can use Docker run. Oh, I forgot to mention that to run this Docker commands, right, you have to install Docker desktop So it includes Docker commands and also Docker Compose, which we'll be using later. So Docker Desktop also comes with a user interface so that we can see what our images built. So just now we built the Nest Docker. You can go to the images tab and you can see the Nest Docker that we have just built 1 minute ago. All right, so now to run this image, you can execute this command. So it accepts a parameter detach. So basically what detach means is basically not attach our terminal when we run our Docker image, because if we run it without the detach, we will basically not be able to use the terminal anymore unless you stop that container. That's for detach. So it basically will run the Docker in the background. Okay, so by default, as I mentioned, Dockers work in isolation. So you cannot access the container itself by default. So you have to publish it. So when we run our Docker, our NestJS application, it runs on port 3000, right? And we can also expose the port that we want to access our NestJS from the host, or for example, in our browser itself. So we have to define it. You can define it as port 3000 as well. So remember, this is the host, and the second would be the container port itself. And then just the name of the image that we want to run. And there you go. You paste this ID, and when we go to our Docker desktop, we can see that our Nest Docker is running as expected. Now let's go to 3000, and there you go, we can access it. So just to quickly show you that if we don't pass these parameters, what would happen? Basically, now our terminal is attached to the Docker itself. We cannot do any commands right here. And also, because we didn't publish it, let's just stop this. As you can see, the Docker image is running, but it's not exposed to the host, so we're not able to access it. So yeah, so that's why we need those 3 parameters. And as you can see, I cannot even stop it. I have to stop it from the Docker desktop, and only then it will have to let go of my terminal. All right, so I'm just going to delete this. So basically, you actually now have the Dockerfile that you need to deploy the NestJS in production. But this video is all about setting it up locally. So how can we do this with just one Dockerfile for both production and dev? We can use the multi-stage build, which is a feature in Docker itself. So we can name this as our base. So normally we have instructions that are both common to development and production. So these are the work directory and copying the package, JSON, and yarn log file. So these are the common things. Now we want to define like a base for development. So for the base of development, you can use the base itself, because that's what's common about it. And then same thing, we are going to install the dependencies. But this time, we're not passing the production parameter because this is for dev. We need the dev dependencies as well. And then same thing, copy all the files after that. And basically, we can just straight away have the command for the dev mode. We don't need to add the nest CLI because it's already part of the dev dependencies. So that's for dev. You can basically have one specific for prod. And basically, this is for prod. So when I build this image, I can pass a target parameter. So if I pass dev, it will look for the dev in the instruction. So it found dev here. Since dev's base is from the base, you would go back up right here and do these two instructions. After that, you will then continue from the dev and do these instructions, and then it's ready to be run with this command. Same thing for prod. If you pass prod, you then look for the base, do these two instructions, then continue from prod again, and run these instructions over here. So if you didn't pass any target, you will actually skip anything in between the from keywords. And as you can see, it still will run as a production. And that's actually not a bug, but like a feature, because by default, Dockerfiles in most use cases are for the production. So that's fine. But again, yeah, ideally you should pass a target to prevent any issues. But just a common thing, we should put anything instruction for prod at the bottom. All right, so enough of that. Let's quickly build this with a target of dev. And then the tag name nest docker context. Okay. It might take a while again, so I'm going to skip it. Oh no, it's quite fast. And then run this same thing, detach, publish to port 3000, and then the name of the Docker image. All right. So let's see, it's running. It might take some time. It's still compiling. And there we go. It's now showing the hello world message again. So our Dockerfile for dev is actually now ready. But the one thing caveat about this is we're actually expecting that any change we do right here should reflect on the running container, but it doesn't, because you have to build it again and run it again. So that's not really ideal for local development. Ideally, anytime we make file changes, it should reflect on our container. So how can we do that? We can use the tool called Docker Compose. So another great benefit, aside from solving that file changes issue, is that Docker Compose allows you to run multiple containers with just one or two scripts. And we're going to need that later for once we run both of our app and our database, which is Postgres. And aside from that, we're also going to use another service which is called pgadmin4. That will be our database admin tool to access our database Postgres in the web. And yeah, Docker Compose is the way to go. So to start, let's create a Docker Compose.yaml file. And we have to define the version. I think this is the recommended version for now. And we have services. So remember, we can run multiple containers or services using Docker Compose. For now, we're just going to define app, which is our NestJS app. And under that, there's a build. So in this build, basically is the Dockerfile itself. So for context, it's going to be period or dot. And then the Dockerfile, which is the file name of the Dockerfile. Dockerfile. And then we can define the target, which is dev. After that, again, we need to publish it. So we can publish it using ports. Same thing, 3000, 3000. Actually, we need to provide volume. So this is actually how we can sync our source folder to the container source folder. So we need to define these volumes right over here. So whenever we make changes to this, we will basically sync it with the container so that both of them have the same files. And that itself will trigger the rebuild of your container. We don't have to rebuild the whole image, just part of the files or the application itself. So let's just try this again. Okay, so now it's working fine. And there you go. Let's just test this out by making a different change. And when I refresh this, there you go. You don't have to rebuild the whole image. It's just basically recompiling the NestJS application. And yeah, this is really great for local development. Now we're ready to basically create the service for our database and the database admin tool. So for database, as I mentioned, we'll be using Postgres. So Postgres has already an official image from Docker Hub. You can go here. And then it's going to provide a restart. Oops, sorry. And this as always. So basically, if our Postgres failed running, it will restart always. For the ports, by default, this image runs on port 5432. So we're just going to expose the same thing, 5432 as well. And if you go to the Docker Hub of Postgres and you scroll right down to the environment variables, it actually mentions that it requires the Postgres password. So that's the only variable you need to define. So let's define it here. For the username and database, we'll be using just the default. You don't want to populate YAML file to keep things simple. It's going to be Postgres as well, as mentioned here. And DB would also use Postgres. All right. Lastly, the DB admin will be using pgadmin4. Is one of the most popular UI for communicating to your Postgres database. So we're going to use that. Same thing, restart always. Ports. So by default, this runs on port 80. But when we access this on the web, let's use port 5050. So similarly, with the Postgres, it also has some required environment variables. When you go to the pgadmin, it has a link to the latest release. And once you go there, you scroll down to the environment variables. Look for the required ones. It's basically the email and the password. So let's define that. I'm just going to use admin.com. Since this is local, this is fine. You don't need to be super secured on this. And for the password, we're just going to use pgadmin4. Later, you'll need this to basically access the tool in order to use it and then connect to your database. All right, let's just stop this and rebuild it again. It might take some time because this is your first time pulling these images for Postgres and the pgadmin4. So I'm going to skip this. All right, so now it's finished building all these 3 images and it is now up and running. You can also verify it on the Docker desktop application, and you can see the 3 of them are running and there's no errors on the logs if you look at them one by one. Yep. So to verify, let's just go to the pgadmin4. So you can access this on 5050 localhost. And it will basically ask you to log in. So remember the user that we use, and the password is pgadmin4. And then it will direct you to the dashboard. And I want you to focus on the servers right here and right click on it and register our in our Postgres database. So I'm just going to name this as Nest Docker and go to the connection tab. So for the host, you might think that it should be localhost, but when these services talk to each other, they basically refer to the host by their services name. So in order for pgadmin4 to connect to the host, we'll use db as the host name. And then let's keep this as 5432, same thing. Database, Postgres. Username should be Postgres, as what is the default here. Same for the password, and save it. And if you didn't get any error at all, that means the connection was successful. And later on, when we try to see all the tables created in the our Postgres database, you can go to the Nest Docker, databases, schemas, and then public, and then tables. So right now it's empty because we haven't created one, but later you'll see one gets populated. And actually forgot one more thing right here. Since our app needs to basically depends on database Postgres, we can add depends on DB. So basically, when Docker Compose reads this instruction, you basically read from top, which is the app, and then looks for the depends on key. If there's one, you will bid DB first. Once the DB is up and running, and then only then you will run the application service. So yeah, I forgot about that, but yeah, just add this over here. Okay, so now we know that our DB admin tool and the DB is also running. It's now time to connect our application to the database. So I'm going to use TypeORM. So it's an object relational mapping. So basically, in simple words, it allows you to use any kind of database service to your application in the programming that you prefer. So in this case, NestJS. So TypeORM basically allows you to write JavaScript friendly or TypeScript friendly way to communicate to your database. So aside from that, for example, for today, we're going to use PostgreSQL as our database. And tomorrow we then suddenly decide to use MongoDB. It allows TypeORM allows you to easily switch to that database without changing anything in the code, but only the configuration. So later you'll see how we configure that. In the meantime, let's install the packages that we'll be needing. So TypeORM, and also NestJS already comes out of the box of NestJS library to easily integrate TypeORM, and then install the PG, which is the Postgres database that we are going to use. I forgot the yarn add. Okay, so now it's installed. Let's quickly go into the app module, which is our root module, and import TypeORM module here, and for root, because this is the root module. For root, and it accepts an object and a couple of things you need to define here, which is the type. So the type of database we'll be using, so Postgres. So it supports a lot of other databases. So there's MongoDB, Aurora, MySQL. So that's what's great about TypeORM. And then basically the host. So remember, it's not localhost, it will be DB based from the name of our service. And then the port 5432, username Postgres, single password, and the database Postgres as well. So some additional keys for TypeORM is the auto load entities. So what is an entity? It's basically in Postgres, those are the tables, and in MongoDB, those are the collections. So we basically want them to be auto-loaded in TypeORM for us to use them. Otherwise, you have to define it and pass all the entities here. But for simplicity, we can just use the auto-load entities functionality by TypeORM. So we look for all the entities within the code. And another one is synchronize. It's basically when you have changes in your schema, you will synchronize it to your database. So that's good for migrations. Okay. So that's all you need. Again, let's run this in Docker Compose. So you don't have to keep this. We keep writing this. We can actually have a shorter one. Add it in our package.json script. So that we can basically just run Docker Compose dev. All right, so now it's up and running again. As you can see, TypeORM module has been initialized. There was no error at all. That means the connection with the TypeORM with our NestJS is successful. This one, you see that there's CSR session token. That's because we have our pgadmin 4 open right here, but actually it got logged out when we rebuild the image again. So after that, we should not cause any issues anymore on the DB admin tool. All right, so just to verify as well, let's create a simple API so that we can verify that the connection to the database is working. So I'm going to create a module users using the Nest CLI. Remember, I created a separate terminal, but my Docker Compose is still running. And then under this users module, I can create a service without spec. We're not going to write tests in this video. And then control it. Also no spec. Basically, you will not create this spec file for tests, writing tests. All right, so as you can see, there's a folder right here. Using the Nest CLI, it will automatically import that module. Same thing right here. I just saved to fix the formatting. And okay, so before we create the service function, let's just also create an entity. It's like a schema for our TypeORM. So it's going to be a class of user. So what are the fields that we need for this user tables or entity? So we're going to have an ID, first name, last name, it's active boolean. Just keep things simple for now. And yep, in order for this to be an entity, you can use a decorator from the TypeORM. And basically each of these fields will have a decorator as well. This will be a primary generated column. So it will auto-generate the ID for us if we didn't specify it. This will be just a normal column. Same thing for here, but for active, you can actually add a default, pass a default value, which is true. And yep, that's all we need for the entity. We can now go ahead to the services. Oh no, one more thing. We need to import TypeORM in the modules. So in order to do that, import the TypeORM module. And for this time, we're going to use for feature. It accepts an array of the entities that we'll be using in this module. So we're only going to use user entity. So we're just passing that. All right, so now we can go ahead to the service and basically inject the TypeORM so that we can use it in the functions we'll be creating. So in order to inject it, basically define users repository. So this term is actually from TypeORM. TypeORM, basically repository allows you to basically directly talk to that table or entity and make call those methods such as like getting all the users, creating a new one, and all that. So this will be a repository of type. And under that type repository is the entity itself. So using NestJS way of injecting, this would be an inject repository. It accepts a entity. And let's make this private so that it can be accessed in the function. So the function that I'm going to create is just to get all users. should be a promise since it's calling from the database of array user. All right, so we can return this. So the user is repository. We can do a get find, and there you go. We can now use this and create an API on the controller. So we're going to use the same name, get all users. Again, promise array of users. Let's inject the service over here. Private user service, and then return this dot user service dot get all users. And I think that should be it. Let's test this out. So as you can see, our Docker Compose is still running. And let's make a request. Oh, we forgot one thing. We need to add a decorator get, so that any get request to the users would be handled over here. And there you go. It returns an empty array because we don't have anything yet. Of course, we need to test this out as well. Let's log into the BEG admin 4. Now, if you go ahead to the tables, now you can see that there's a user table. Let's quickly view inside of it. And I'm just going to add one row over here using my name and last name. I'm not actually sure how to save here. I'm just going to exit this. It will pop up saying save changes. Let's save that. Okay, let's run the view again. As you can see that there's already one row with an ID of 1 is active true. Let's see if our API returns the same. And it did. That means our NestJS is now connected to our database and can make different Postgres calls. All right. So you might think we're already done, but just a few more things to add. So if you remember how we initialize Postgres, normally these configurations should be outside of the code. We don't want to hard code any of these values so that it makes our application more portable, and we can deploy to production if we have production specific configurations. So let's export this. We can actually use .env. So, in most Node.js applications, we use that. But in some cases, you have one for development, one for production. Normally what you do is basically replace those values. But actually, NestJS already have a module out of the box for you to use for this kinds of configuration. And that is called ConfigModule. So in order to use that, basically install that dependency at nestjs/config. Okay, once that's installed, I'm just going to run the Docker Compose again. In the background, it will rebuild and install that dependency as well. But in the meantime, we can start writing code. We basically import it in the root module as well. For root, same as TypeORM. And it accepts an env file path. So it's an array. So in this case, it will basically tell which file to load, which env file to load. So you can have multiple envs depending on which environment you want to run. You will have a specific env file. So in the convention that I use is basically stage dot, and then you interpolate using the stage environment. So this will be the key to basically tell which env file to use. So let's create those env files. So stage.dev.env. and then stage.prod.env. So you might have more, but let's just start with these two. So basically, when we run the scripts, so for example, dev, we want to pass a env variable depending on that stage. So would be stage dev. Same thing over here for debug, and for the 3 tests right here. And then, of course, for prod, our stage would be different. All right. So I think that's it for that. Let's then go back to the modules. And right now for TypeORM module to use the configuration service, we can directly use it because it's going to compile right away. We can directly use it until it is loaded. So in this case, we can actually use a dependency injection, and we will need to use for root asynchronous because now it becomes asynchronous. Let's just comment this up for now. And yeah, you can import any dependency you would like to use. Then inject it. And there's another use factory, which is synchronous function. So how can we use ConfigModule? Basically, we need to import it and then inject the config service right here. And now this, once you inject it, it becomes available. Config service right here. Just pass the type. Then return basically this right here. So now we can basically replace this and get each of these values from the env file. So we haven't defined it right here. Let's go ahead and define it. I'm also going to add the port right here because sometimes you want to run the NestJS application on a different port. So let's make it more portable as well. So in this case, oops, let's just stop this one now to prevent these errors right here. And then the DB host, so it's DB port 5432, username, postgres, DB password, database. All right. So I'm just going to use same for prod, but ideally you shouldn't be pushing the actual values in production because that's sensitive. We don't want that to be part of the repository commits. So just a note on that, but in the meantime, I'll just copy the same thing. All right, so now it's basically, we can use config service to get by its key. So remember the key, DB host, same thing, DB host. All right, so just going to copy that same, just replace the key, DB host, DB port, password, database. All right, so that should work fine. Let's delete this. All right, I might have to restart the whole thing because we added new files, which was not part of the build. And while it's building, I'm just going to import and use import from the process.env. Remember, we added it over here. Let's just use that. And it's better to log it as well, just in case. And NestJS also has a logger module that we can use. Really, really great. Log application listening on port, and then the port. Okay, let's just wait for it to build. All right, so now it's up and running. You can see as well that our new log is added here. Application is listening on port 3000. So that means our changes are working. Our config module is working, and there's no errors from the database. Let's try the users API again. And there you go. It still returns the same array of users. And yeah, now one more thing just before we end this off. Basically, for example, I give you a scenario. We forgot to define username over here. You would get the same message a while ago, basically unable to connect to the database. Sometimes that error actually is not very helpful. You might think that your database has some problems, but actually you probably just forgot the configuration. In order to prevent that, ConfigModule comes with schema validation. So you can pass your own custom function right here, or you can use the recommended library by NestJS, which is called Joy. So I'm going to add it over here and basically run the Docker Compose again in the background. So while waiting for that, I'm going to basically create a config.schema.ts and then import joy or as joy. Okay, so now that's important. Basically, we just have to export the cons, which will cause config schema validation, and then use the function object because it's going to be an object. Our configuration is object of key and key value pair values. And the first one is stage. Remember the stage that we define here. We need that as part of our env configuration. So that should be string. You can do it like this, joy.string, and it is required. Again, you can do the same thing for port. This time is a number. You can even add your default. So basically, the default will be 3000, and it's also required. So same thing for DB host, DB password, and DB database. I'm just gonna repeat those here. Okay, but port should be a number. And again, you can write a default 5432. And that's really it. Now we can try and use this in our config module. Schema, and import it right here. And this should be working as fine. Okay, so it's now up and running again. As you can see, there was no error because we have defined everything in the environment configuration. So let's try and test this out. So let's say I forgot to add the username in the DB and I try to run it. Okay, as you can see, I forgot to define the DB username environment key. He has thrown an error, basically saying config validation error, DB username is required. So that is really helpful for in cases you forgot to define the required configuration instead of just getting unable to connect to the database, which is a bit generic error, and you will have to debug what's wrong. All right. Just to complete this off, we want to be able to not just run the dev, but also run the scripts along with the database. So sometimes you want to write tests and you don't want to mock the database. You can actually use directly the local database from the Docker Compose. All right, to do that, basically create a couple of compose files. So one is for production, because you also might want to run the target production. Okay, I'm sorry, I'm going to the Dockerfile first. Basically, define the different stages in tests. So remember, there's 3 tests. One is just test, one is watch, one is with coverage. So let's create different stages here. So this time I'm going to use dev because same thing, it will also install both dependencies and dev dependencies in the test. So as you can see, the dev base is dev, and then dev's base is the base. I hope that wasn't confusing. Basically, we don't have to do these two scripts right here, but we might want to override the node env to test. Okay. So I actually forgot to add the node env for development. Ideally, should have that. Same for production. And this would run tests. And same for test coverage and test watch. This time we're going to use tests because all of them will have the environment of tests. We don't need to do that here, but change the command. All right. So for watch specifically, we have to do some special scripts right here. We basically have to define the Git work tree to be /app. In the container, we are using /app. So because test watch basically depends on Git and the Git changes. That's how it knows what files has changed. So we have to define what is the Git work tree, as same as the Git directory, which is app.git. Then we need to install Git. So apk add git. So it's a Linux command to basically install Git in the system. All right. So after that, then if you run this environment on the test watch target, you will then listen to file changes. So next, again, we have created a YAML file. Basically, we don't have to rewrite the whole thing. Basically, this will just be the contents of what you need to change. So here we want to change the app build target tutor. So basically, it will just append it. Look for the things that you have changed. We only change the target, but it will retain all the other configuration. So that's great. We don't have to repeat anything from the different targets. So this target is for production, one for test, one for test coverage, the YAML, one is for test watch. So for tests, it will be the same as production, but with a target of tests. Same for coverage, test coverage. In case you forgot, target basically means the stage builds right here. So this will be watch. The unique thing about watch as well, we want to basically add another volume. Remember, we had to do it for the app, the source folder. For the watch, we want to sync our .git with the app.git. And I think that should be it. Let's just write the commands over here. So for S1, basically can run it by basically using the -f parameter, which you define what YAML to use. So first, the Docker Compose YAML, and then append the test.yaml. So another unique thing about this, and then up, is that when you run tests, basically after running tests, you don't need the application or the database and the admin tool to be up and running. So you just want to exit from that. So you can use exit code from and then the name of the service. So once application is done running the tests, basically exit. Same thing for coverage. Just that it's a different YAML. Again, for watch, We don't want the exit. But we use the watch YAML file. And lastly, the prod, which is using the production YAML file. And there you go. So basically, let's try to run Docker compose test just to test it out. All right. So as you can see, we have run the test mode. Basically, you will run the test, and after running the test, the application service would exit with a code 0. Docker compose would listen to that and basically recognizes that it should stop all the other services as well. As you can see, the database in DB-admin has stopped. All right, so we know that everything here is working fine. You can also test it on your own to run the coverage, and the watch, and the production, and that should be working fine as well. So actually, that's all in this video. So I hope this was helpful for you. And if you like this local development setup, please like this video and share it to your friends and colleagues. And as always, don't forget to subscribe and hit that notification button. So thank you once again, and goodbye.